Welcome to my presentation of a NoSQL database solution for storing vehicle information. The company that I will be modeling is a car park operator who owns parking spaces near a shopping center for people to park their cars while they're out. Their main business practice is that someone who goes shopping will driving to the car park, and as they get to the entrance, their number plate will be scanned, their license plate registration number, and it'll be stored in the database, and then when they leave, they'll pay for the amount of time that they used. The use case that I'll be modeling with MongoDB is a driver pulls up to the entrance of the car park, and the machine queries how many cars are currently in the database to find out how many available spaces there are in the car park. And then if there's available spaces, it'll scan his license plate and open the boom that he can drive in and issue him a ticket to say how long he can park in the parking lot. I chose MongoDB, a NoSQL JSON document database, to solve this problem. And the reason I chose MongoDB is because it offers a flexible schema, or schemaless, where the schema is just managed by the application. And this is quite convenient because it means that in future, if any fields need to be added for more information about cars or vehicles, then it can be quite easily done without having to modify a table in SQL. The additional fields can just be added into the JSON documents. It also is a good choice for database because the data model doesn't require any joins between the tables or collections, and so SQL isn't necessary. And that's one of the main reasons SQL is used, is because it provides joins, but in this case, because joins aren't needed, I went with NoSQL. And another reason why MongoDB makes sense for this use case is that it can scale bigger in future. So if they need to have, say, many different car parks around the country storing millions of vehicles, they can partition the database in a sharded cluster to get a larger scale than what would be possible with a SQL database like Postgres. And another reason why MongoDB is a good fit is that all the items have unique IDs because every car has a unique registration number on their license plate, and so the data fits well to this data model. So this is the data model diagram that I made of the different collections of entities that will be stored in MongoDB. So there's a vehicle, ticket, and fine. For the vehicle, the ID, or the primary key in SQL terms, is the registration number of the car, and then there's some other details about it like the brand and the color and the fuel type, so whether it uses diesel or petrol or electric. And then there's also ticket entities, and they store, for every car that parks there, what time they started parking and how long the ticket lasts for and how much the customer will have to pay. And then there's the fine entity for if someone doesn't pay the correct amount and they're issued a fine, then the fines collection will keep track of those. I'm now going to do a demonstration of the Python code that's used to access MongoDB and to perform the basic operations of create, read, update, and delete, and also some aggregation. So to start off with, I've got object entity maps in Python for using mongoengine to create the collections, and these classes are one for each collection, so vehicle, ticket, and fine, and they all have the attributes needed, or the fields needed, with the field type, so integer or string or date, and then also if it's the primary key, and if it's required or not required, and if there's a default value, what it should be. So to connect to the database, it just calls connect with the name of the database to connect to. And then this is an example of the create operation, where I've got the data for a car stored in a Python dictionary, and that's unpacked into the vehicle class constructor, and then the save method is called to insert that car into the database. And then this load data function just loads a lot of data from a CSV to populate the database. Now to perform a read operation, the vehicle class has this objects accessor on it, and then I'm filtering by registration number, so that will just return a single car because registration number is unique, and then I get the first result from the results that are returned and print it out. The update operation performs the same as the read operation, but instead of just reading the details, it changes the v5c date to a new value and then calls save, and that will perform an update in Mongo. And then the delete operation again just finds a vehicle by its registration number and then calls delete, which will remove it from the collection. And now to do some aggregation. Firstly, this is just a simple aggregation using filtering by the brand of car, so this is just filtering by brand Ferrari and then counting how many results are returned. And now a more complex aggregation using MongoDB pipelines. This filters down to all of the cars that have diesel fuel type and then groups them by their brand and then sorts by the brands which have the most diesel cars down to the ones with the least, and then limits it to the top 3. And then it prints out the results. So it'll print out the top 3 brands for the number of diesel cars. And then also in my Python file, I've got some ticket data that gets inserted to populate the tickets collection, and then also a fine to be inserted into the fine collection, so that all 3 of the collections have at least one entity. And then I've got, finally, the main success scenario of the use case, where a customer comes to the parking lot and it counts how many cars are currently parked there, and then minuses the total number of parking bays from the cars parked there to get the number of available bays, and then it just prints out how many available bays there are in the parking lot. And then if there's an available space, it inserts the new car by putting all the details into a vehicle and then calling save, which performs the insert operation in Mongo, and then it also inserts a ticket for that car to say how long the car can park there and what the payment amount will be. And now I'm going to run this script on the database, and you can see the output. It performed the insert, update, read and delete, and it performed the aggregation of the number of diesel cars, and then it found out how many available bays there are in the parking lot.